Thank you everyone for joining us today. And this is an exciting day for me today because I have this opportunity to talk about this project called K8s. So once again, thanks to everyone for joining the podcast today. And in this podcast, we'll be learning how to build and deploy Go application on Kubernetes with Go. And today my guest is Jason Hall. Thank you everyone. Thank you, Jason, for joining us today. How are you? And let's explain the brief because when we met, you are in Red Hat.
Yeah. We met. We did one of these last year to talk about shipwright. I think, right? Like
Yes, absolutely.
Yeah.
And today we're talking about Go. And first, let a brief experience like how the life is going in the chain guard, the building with the supply chain security and these kind of stuff. And plus your like discovery of Go project.
Yeah, things are great at ChainGuard. I'm surrounded by fantastic people. Somehow they let me join the club, so everything's great there, and I'm excited to talk about Co and hopefully take people's questions and give people's feedback. I'd love to chat about it. So yeah. Oh, you're muted. Am I muted?
I'm mute line. And so I say, just saying, the engine is also in the chat. That's great to see you, engine.
Oh, yeah.
So let me share the screen so you can talk about Go.
Yeah, you seeing this?
Yes, absolutely. I can able to see it.
All right, great. Yeah, I'm going to do a quick presentation and then a little demo, and then I think plenty of time for questions and any other conversation. So yeah, this is a talk about Co, making Go containers easy. My name is Jason Hall. You can find me on basically everything, and I'm Jason H. Let's jump in. So if we're going to talk about making Go and containers good, we got to start with basically the usual best practice, which is Dockerfiles. Where just to level set, throughout this talk, I'm only going to talk about Go development, basically. If you're writing other languages, Java, Node, .NET, Python, Ruby, anything else, most of this probably won't be useful for you, but I will try to make some of it useful near the end if I can. So anyway, we're talking about Dockerfiles. This is the sort of standard stock Dockerfile that you find on docs.docker.com. This is how they recommend building a Docker image for Go. We'll go through some of these lines, but first, there's actually a second one they recommend, which is the multi-stage Dockerfile for Go. That one does all the same stuff and then just does a little trick at the end. So let's go through this line by line. From golang as build means go fetch the Go image and put me inside it. Workdir, put me in this directory, copy my Go mod, copy my Go sum into here, run Go mod download, copy all of my Go files to here, and then run Go build and put that build binary at /my app. And then the next section, this green section, is a multi-stage Dockerfile build. So we will pull the image, pull this distrolist static base image, copy the built binary out of the last stage, put it in here, and set the entry point. Whew. Okay, that was a lot. Feel free, I will come back to this also. But this is sort of the standard stock way to build Go applications with Dockerfiles. This is, again, just from the official docs on docker.com. A pop quiz. You probably weren't expecting this. I'm going to ask a bunch of questions about this. There are no wrong answers, except some of these answers are very wrong. One of these had a CMD, and one of these had an entry point. What is the difference? Does anybody know? Maybe. Doesn't matter if it's one or the other. For the workdir /source in this one, does that matter? Do I need to copy my Go mod first or copy my Go sum first, or can I copy them at the same time, or does it matter? Nobody knows. If I run Go mod download first, do I still have to, can I copy my Go files first and then do Go mod download, or should I do it the other way? Doesn't matter. What if my Go files aren't just in the root of the path? It's, I need to copy from all the subdirectories. Does this build here reuse my Go build cache? If I run this twice with small changes, does it rebuild? taking into account my Go build cache? Who knows? And as a bonus question, how do I get this to build for other CPU architectures? I know it's possible. I'm sure I've read a blog post about it. But how do I do that? And how do I do that for Windows if I need a Windows image? Again, some of you may be screaming at your screen right now. You definitely need to run gomod download first or whatever, or this is how you copy everything in every subdirectory. That's not really the point of this. Throughout this talk, I'm going to make, it may sound like I am bashing Dockerfiles. Dockerfiles solve a specific problem, but they're also kind of complex, right? Like there's a lot of stuff you have to remember, CMD versus entry point, the ordering of stuff really matters. And it can be really hard to misuse. And a lot of times, like if we don't know the answer to which one should go first, we just sort of copy from docs or another repo we've successfully built from, and we modify it a little bit until it successfully builds an image. And it's actually in practice really easy to get something subtly wrong and not know whether that, flipping the order of these two lines makes your build slower than it needs to be, or insecure, or even if they're both correct, it's just very easy to get into an argument with your coworkers about the specific cargo cult and dogma of whether this line goes first or whether you need to copy this in this order or whatever. And aside from the whole Dockerfile issue, the Dockerfile syntax and best practices, I have some problems with Docker build itself. Docker build, again, is a great tool, fantastic, very flexible, does a ton of stuff. Every run directive in a Dockerfile starts a new container for isolation. This is actually really important, and the whole reason you use Dockerfiles. It prevents unintended side effects in those build steps from sort of breaking out and tainting your host machine. You can do in a Dockerfile rm-rf, right? And it doesn't delete stuff in your actual machine. It just deletes stuff in that container environment. But for doing this for Go, it's kind of overkill, right? Like this Dockerfile back here isn't doing anything that crazy, right? It's really just running Go build. And we're pretty sure that that's not going to have any negative side effects on our host environment. We run Go build all the time. We're not worried about it. Why do I need to run that in a container? This also requires Docker, which has a couple of problems in practice. One is if your CI environment is itself a containerized build system, something like Google Cloud Build, which I'm very familiar with, or Tekton, which I'm very familiar with. Those run your build steps inside of a Docker container themselves. And so if you need to run Docker inside of Docker, your options get kind of hairy. You can host you can mount the host Docker daemon, which is terrible for security. Please never do this in any serious capacity. You can run Docker in Docker, which is slow and just stacks another turtle on top of things. And there are some other options, some more elaborate things to do with rootless or daemonless or more exotic things. But I think another thing people don't talk a lot about is on your development machine, it drains your battery. It's running all the time. Even if you're not running any actual containers, right? Or maybe you ran a container, 3 weeks ago, and it's just still sitting there chugging away, waiting for you to come back. And in the meantime, it's using a lot of battery, right? Like I usually don't leave Docker on, but one time I did for a few weeks just to see what would happen. And I came back and my laptop said it was using significant energy. I don't think I even had any containers running at the time. This is not scientific at all whatsoever, but I looked in the system monitor and it was using almost twice as much power as Google Chrome, right? Which I use daily to do everything. So what is Docker doing that it's just sitting there doing all of this? And I want to be clear, again, Docker Desktop does provide value, right? Like if you need to run, if you want to run a kind cluster, you need Docker to do that, or Podman. Again, there are other options. But if you are getting value out of it, you should pay for it, right? Docker Desktop costs money now. But there are situations where you might not need that. And that's what we're here to talk about. So sort of whenever I see things getting really complex, right, I look around at that Dockerfile and I don't understand what half of the lines mean or whether they need to be in exactly that order. I like to sort of take a step back, take a beat, and say, what am I actually doing? What is the actual core of the thing I'm doing? And at the end of the day, all of that Dockerfile is setting up an environment for me to run Go build in. It's pinning the Go version that I use to build it. That's good. But it's mostly setting up an environment for me to run Go build inside of, and then running Go build. And hopefully I got the lines right that I don't have to run Go build if I don't need to. Like a lot of those lines are there in that order to avoid running Go build if you don't have to. That's to make your Docker build faster. So you run Go build and you put your built binary over here called my app, and then you slap my app on top of a base image in that multi-stage build example. It was slapping it on top of a distroless base image, and then you make that binary the image's entry point. And then, oh yeah, I do this all the time. I Docker build and then I forget to push, and then I wonder why I can't pull it, or why when I'm pulling it, it's not the same thing. You got to Docker build and then also Docker push. Don't forget about that step. So really all you're doing is setting up an environment for Go build, running Go build, and then sort of moving some things around. And that's exactly what Ko does. Instead of Go build my command / app, you run Ko build, which does the same thing. It invokes the Go. It invokes Go build. It builds that binary and puts it on top of a base image, a distroless base image by default. It makes that binary the image's entry point, and it pushes it directly to the registry. You don't have to forget to run Ko push or something like that. It's just Ko build goes straight to the registry. And it does all of this without having Docker installed on your machine or running on your machine. And it shares your Go build cache by default. So if you're running Go tests and Go builds and Go, all of your regular Go stuff, and then you do Ko build, it's not going to build from scratch. It's going to reuse that build cache by default. There are some caveats. There are some things that Ko assumes. One is that cgo is not enabled. We assume that cgo enabled is 0. If you are using cgo, there are ways to make it work, but it's kind of advanced and not super easy. If you don't know if you're using cgo, it's pretty safe to assume you don't. Basically, everything in the standard library doesn't require cgo. And if you try to co-build without cgo available, it will tell you very loudly. So unless you know that you need it, you probably don't. And Ko will work just fine for you. Ko uses your local Go toolchain and environment. So remember when I said before that the Dockerfile would let you pin to golang 118 or whatever. Ko just uses whatever Go version you have and whatever Go environment, whatever Go path, Go root, whatever that you already have. If you need to pin to a Go version, there are ways to do that, but mostly that's a very small nail to hit with the Docker hammer if that's all you need. Ko won't install more OS packages for you. You can't like APK add stuff. You can't apt-get stuff inside of Ko. If you need those for your app, for your image, you can put those in your base image and then build on top of that image your Go image. I would recommend using APK-o for that. That's another tool we're building at ChainGuard. Happy to talk about that some other time too. And it builds a container image with one Go binary as the entry point, just like our Dockerfile examples before. And the last one is you need to set the Ko Docker repo environment variable. This tells Ko where to push that image whenever you build. So these are sort of the warning lights to get out of the way before we get to the good stuff. But if this is you, if you're not using cgo, if you're comfortable using your regular Go version, you don't need any OS packages, or they're in your base image, then this is a good fit for you. So let's talk about Ko Docker repo for a minute. In order to use Ko, you have to tell it where to push your images. You can set this once. You can set this, in your bash RC or something, and just say, anytime I run Ko, I want it to push to registry.example.io or GCR or ECR or GitHub or whatever. There are a couple of special values for this, which are useful, I think, for a lot of local testing, especially. One is co.local. If you set it to co.local, it will push to your local Docker daemon. This requires that Docker is running. So you can do Docker run and then co-build this image just as one little a bash one-liner. You can also do kind.local if you have a kind cluster to set up a Kubernetes and Docker cluster. You can do co-docker repo equals kind.local, and it will push directly into your kind cluster where you can do a bunch of fun stuff there. We'll come back to some of the Kubernetes workflow integration stuff later. But this is all sort of preamble, caveats, setup. Now we get into the good stuff. The theme of these next few slides is going to be that because Go constrains the problem space to just Go, to just saying we're just going to build simple Go containers, we unlock a ton of awesome features. If you are just building Go images, we get to constrain the problem space to just Go, and then we unlock a bunch of cool stuff. This one is not actually related to that, but Auth. Let's get Auth out of the way because I feel like any good demo starts with like, here's all the awesome cool stuff, but Auth is a huge pain to set up. The way that Go works is if you can Docker push, if you have already set up Docker Auth on your machine, you can co-build. You don't need to do anything else. It uses the same Docker Auth configuration, including cred helpers. If you can Docker push, you can co-build. There's a command called co-login. It's exactly like Docker login. It does the exact same thing, but it just exists so that you don't have to have Docker installed. If you already have Auth set up, you never need to run co-login. As a bonus, Go also includes all the code and all the configuration for all of your built-in cloud credential helpers. So if you're pushing to GCR or Artifact Registry or ECR or Azure Container Registry or GitHub's Container Registry, and you have those environments set up for you, you don't have to have the cred helpers installed. Go just acts like you do. It just does the same stuff that they did. So that's usually a super huge benefit in CI environments, especially. You don't have to set up, Go and a cred helper. You can just say, I'm inside of GitHub Actions. It automatically knows how to push to my GitHub Container Registry. Another huge feature of Go, which is, again, made possible because we rely on Go, is speed. Go builds are pretty fast, and especially incremental. If you make if you have a huge app, but then you make a tiny little change to it, Go build is pretty fast just on that. So this takes advantage of your Go build cache for incremental Go binary builds, and then we do something on top of that where if you have an environment variable set called co-cache, we will stash that information off in that space and not have to rebuild a bunch of stuff. So we can actually avoid calling Go at all if you have the co-cache environment variable set. With the co-cache environment variable set, a no-op build, a build with no code changes, is about 1 second, which is very, very fast, and basically fast enough to run it. Anytime you make a change, you should run Go. You can. You don't have to, but you can run Go build. Another huge feature in Go that it really, really shines on is multi-platform images. Again, this is possible because we take advantage of Go doing all of the hard work for us. So Go does cross-compilation just out of the box. If you say, hey, Go build this binary for Linux ARM64. I'm not on an ARM64 machine, or I am, but if I'm not on an ARM64 machine, it would go build a cross-compile a binary for that platform. And Go takes advantage of this by saying, if you set the platform flag to all, it will build for all of the platforms supported by your base image. The default distro list base image supports 8 architectures out of the box. I'm not going to name them, but the big ones are Linux ARM64, AMD 64, 32-bit ARM in 2 variants, and a couple of others. Anyway, a bunch of other ones. This is really awesome, especially because basically ARM is on the way up, right? Like ARM nodes are available on every major cloud. They have pretty well demonstrated cost savings benefits, and I don't see any reason for that to slow down in the coming years. I think ARM is going to be a really big thing. So rather than figure out how to make your Dockerfile build a multi-platform image, you can just tell Co build it for all the platforms. Or if you want to, I mean, it's wasteful if you only want to use it on 2 of those platforms. You could say platform, Linux ARM64 and Linux AMD64. And Co actually also supports Windows out of the box. If your base image provides a Windows flavor, it will build for that platform too, with no extra work. It's not a different command line. It's just co-build platform equals all. And all of this is really just possible because Go does all the hard work of cross-compiling for us. Co just has to build that image for each platform and then sort of put it on top of the image and then stitch all the images together. It doesn't make it any harder on you as a user. I told you I'd get back to the Kubernetes YAML integration, and here we are. So Co was originally actually built to satisfy the needs of teams building for Kubernetes. It came out of the Knative project and the Tekton project. And one of its tricks is a little bit of light YAML templating. So as we see in this example here, this isn't an actual image reference, right? This is an import path. So this is a thing I could go build github.com/my-repo, whatever. If that image starts with ko:// and you run co-resolve on this instead of, if you run co-resolve on this file, it will scan the YAML for anything that starts with that prefix. It will build that image, and it will replace that image in the YAML with a fully built image reference by digest. So it will take in the deployment YAML, do all the builds, and then spit out to standard out this resolved file with all of these built image references. So you can write it to a release.yaml and share it with people, release it on GitHub, or you can pipe it to kubectl apply to apply it directly to your cluster. And this is actually so common that we basically made a little shortcut for it, which is just co-apply-f deployment YAML. That does all the builds. Any build it can find, it does it. It replaces that in the YAML with the built image reference, and then it applies it to your cluster. So the effect of this is it really makes your containers invisible. The build process is just kind of another part of just apply my code to the cluster, right? There's no image even most of the time. You just say, here's my code, here's my cluster, code, make it to the cluster. This actually works even with non-Kubernetes YAML. It's not specific to Kubernetes. Any YAML file will work. If it has a the co:// prefix, it will find it, it will build for it, and it will write it to standard out, which can be useful for things like customize, Docker compose, anything that uses YAML, which is basically everything these days. Another place where Co leans on Go to give it really, really awesome features is SBOMs. So SBOMs are the golden child of 2022. Everyone's building SBOMs these days, and Co is no different. In Go 118, images built with Go 118 binaries built with Go 118 include a bunch of information in them about all of the dependencies that went into that binary. In Co, what it does is it builds that, and then it extracts all that information, and it generates SPDX or Cyclone DX SBOMs from that information. And then it publishes that SBOM to your registry right alongside the image. And as Go releases, add more and more and more relevant build information, Co will pick that up and include it in your SBOM as well. So you can use a tool like Cosign to download the SBOM that Co pushes. This is an example of actually Co's own co-built image. Co builds its own image using itself. You can do Cosign download SBOM of the Co image and then list all the package names that Co depends on. And you see there we depend on Azure and AWS and all these things, mostly for the credential helpers. Multi-platform images actually build SBOMs for each platform-specific SBOM, build platform-specific SBOMs for each platform-specific image. That's complex. and then networks them all together so you can get from the multi-platform image to each platform-specific image to their SBOMs to their dependencies. Shameless plug for ChainGuard Enforce here, because I work at ChainGuard and I should do a shameless plug. We take advantage of this a lot to write policies and let you enforce, like, don't let something run that depends on, you know, this particular library or this library at this version. We're dogfooding this right now, and it's great. ChainGuard uses Co for basically every image it builds. So we're dogfooding every day. All right, that was a lot of stuff, and I'm going to do a quick demo if I can figure out how to do that.
And yes, Jason, we have few questions if you want to address. Yes.
Yeah.
So
let's do questions.
Yes. So Engine is saying, like, can Co uses nerdctl or does it need Docker CLI?
That is a good question. So Co, you mean for co.local, right? I think, I don't actually know. I haven't used nerdctl much myself. I think that it would work, and if it doesn't work, then it is something we should make work. I don't think there's a reason not to do that.
Yes, and also another question for the engine theory. So how does KO resolve would fit into the GitOps flow?
Yeah, so I think there are a lot of things that a GitOps flow entails, but one of them is right, like Co could generate, could resolve a YAML and say, put these images into production, right? And then GitOps just says, this is the state I want my cluster to be in. Watch that state, make sure that state is the right way. And then when you do another release or push another change, your CI can do another co-resolve, generate, this is the state I would like GitOps to make go do, and then GitOps would pick it up and do that. Though I don't have much hands-on experience or anything with that. So if other folks have other things, successful workflows for GitOps and Co, I'm all ears.
Yes, and one more. Is there a co-resolve for Helm values.yaml planned?
Yeah, so it should work right out of the box. Like I said, co-resolve doesn't know anything about Kubernetes specific YAML. It just scans through YAML and says if there's any map value that starts with a KO : // pick that up, build it, replace it, and spit it out. So it should work just fine with Helm.
Yes, and for the last one, what's cri-o's relation with Jib and Fremini's BFF?
Oh, definitely BFFs. Absolutely BFFs. Jib is you're jumping ahead a bit. I have a slide about Jib, or a section about Jib. But Jib is basically the predecessor of Co for Java. So instead of doing a Dockerfile build with Maven build this jar and then put it here and then run the jar when the image starts, Jib just does that inside of Maven. So it also doesn't require Docker. It also has a lot of speed benefits and tooling benefits and security benefits. It came before Co and I think inspired a lot of the stuff Co was doing.
So all of these questions we have answered. Let's start the demo.
Oh yeah. We need to do that. And down, do we see this? Is everyone seeing this?
Yes, absolutely. I can see this. So it's good to see. Just you can, if you hate this, just create more font.
Bigger?
Yes.
That seems to be, well, I can make the window smaller. How's that?
Yes, absolutely. That's perfectly fine. Perfectly fine.
Okay, let me get my script together. All right. So we're all seeing this, right? Okay. Okay. So here I am. I'm inside of the Tekton code base. Tekton is a heavy user of Co, and one of the first users of Co. So I'm inside the Tekton code base. I have set my Docker repo to a GCR repo. So that's where co will push anytime it's run. I don't have Docker running. It's like you don't have Docker running. I can't run Alpine. And there's no Docker files inside. Find. No, not file. There's like a couple of Docker files in the repo. Technically, one of them is in a test and one of them is in here. So there's no Docker files of note inside of this repository. So we're going to browse around the code base a little bit. We're going to go into in here. We have a controller. We have an entry point, webhook, a bunch of other apps inside of the Tekton installation. We're going to co-build the controller. This should be pretty fast. I already built earlier today to make sure that this wasn't going to be. Yeah, so that was Warp. Tell me how long that took. That was 7 seconds to build that image, but it was basically a warm build because it had already built that before. And the last line here, it's kind of hard to see on the screen, but this last line here is the image that it built. So this is the fully resolved image reference by digest. I can, if I had Docker running, I could Docker run that image. But again, I don't have Docker running. But I can share that with someone else. I can say, like, go run this image, CI run this image, put it in a cluster. Next, I want to show, this is the controller YAML for the controller deployment of Tekton. Where's the, so in Tekton's controller YAML, it does that co:// prefix. It actually also has these other things, right? So it's the Tekton controller also needs references to other images to run. So it has these other things in here, and we can scroll down some and see a couple more. So I will co-resolve that, all that config. There's also other YAML files inside of that directory. So that controller is one of them. There's a webhook. There's other stuff. It built all of that, and it's done. And I can go into my release.yaml. This looks almost exactly the same. So there's other pod security policies and stuff. I want to find that image. The image that it wrote is, it built that controller binary and put it here. And for the kubeconfig writer, it built it and put it here. And for the git image, it put it here. So it didn't just do one build just now. It just did, I think, 9 builds. And again, it's pretty fast because I had built this earlier. But 9 builds in like 9 seconds or something like that. So, so that's basically, I mean, that's the whole co-resolve thing. I don't have a kind cluster running right now, but I could co-apply that if. Oh, I am running a cluster. Oh, awesome. Okay, so it's publishing all of that stuff and should just go there and be fine. It's creating all this stuff, and it'll just keep doing that. We're past the build part now. Now it's just doing all the Kubernetes creation stuff. All right, I'm done watching that. But basically, that's applied to the cluster now. So I mentioned multi-platform images. Let's do co-resolve platform all. So remember, that's 9 images that are getting built for 8 platforms, because we're running on top of the distroless image. You can see it's building for S390X and PPC 64LE and ARM v7 and 386 for each of these images. So it's actually going to run and build, what's 8 times 9, 72 different images and push them to the registry, and then stitch together a multi-platform image for each of those. 72 distinct builds are happening right now. Should be pretty fast because I did this earlier. It's screaming by. And normally, I mean, in your regular day-to-day development, you're not going to build for every platform, right? This is really something you're only going to do when you're like, releasing the full release to people. Build for every platform on Earth. So that took, what, a few seconds, something like that. And Tecton actually also builds for Windows in its releases. It doesn't do it for the regular like local development, but in their CI pipeline, they stitch together a Windows image and then build that too. So last thing I want to show is in here, you'll see some lines that say published SBOM for JSON chain guard get init.sbom. While we were building all of those things, we were also publishing SBOMs. So we can do a cosine download. Actually, let's build an image and then get its SBOM, right? Building, downloading SBOMs. Okay. This is yeah, anyway. So this is the SBOM for that image I just built. This is in the SPDX format. You can see that it depends on SIG's K8s.io/JSON. It depends on Knative PKG. It depends on K8s utils. This is, information about every dependency of that image. And I can share that with people. I can scan on it. I can alert when a bad thing is in there, because Ko built those SBOMs for me. And that's, again, Tecton does this for every image, for every platform, including Windows, with SBOMs, without writing any Docker files. There's, again, not a single Docker file in the entire repo. So that's the demo. Let me go back to my slides real quick. But yeah, that's the demo. Are we back? We're back on. Yeah. Great. All right. So yeah, just another quick love letter slide to Go. The only reason Ko is so great is because Go is great. Go gives us fast builds. It gives us secure builds that we don't have to worry about any negative side effects of. We don't have to worry about Go build, deleting every file or scraping API tokens or anything. Go gives us fairly reproducible builds, especially if you're running on the same machine. Running Go build twice won't produce a different binary. So that helps us speed up a lot of things when we want to push images. It gives us static binaries, so we don't have to care about the C libraries that we depend on. Everything's just bundled up into those binaries. It gives us cross-compilation, which makes multi-platform images really easy. It has this nice import path convention where you can say this this string represents where this application lives, and that gives us that YAML templating I talked about before, and it embeds dependency information that we extract and generate SBOMs out of. So that's my love letter to Go slide. There's some related tools. We talked about Jib earlier, but there are some related tools. Ko builds on top of distroless base images by default. You can the distroless static base image is the smallest, simplest one, but if you need something that includes some other tool, APKO is a good tool to build that base image from. There's a GitHub action to install Ko, and recently at ChainGuard we've been playing around with a Terraform provider for Ko, so you can actually, if you're not using Kubernetes YAML, if you're using Terraform to declaratively describe your infrastructure, you can also just slip in Ko builds in there and say, build this image and deploy it to this place. Like I mentioned before, there's Jib for Java. It also optimizes heavily for one language ecosystem and makes that really easy if you are using the Java ecosystem. There's also recently another one came out for .NET called CoNet, which is amazing. Ko is so great that it's got spinoffs. And yeah, I'm really excited to see what else people come up with. I've heard rumblings of a Rust Ko. I'd love to see that. But yeah, so that's Ko. That's the whole thing.
Yes, absolutely. Thank you very much. Wonderful, wonderful that. And I think the one question, like I think, came into my mind, like why, like like all of the thing, like the previous steps we see, like first you write the code, and then you compile the code. Then in a container, you first write the Docker file in it, and then you push the code into the GitHub in the Docker Hub, and then you deploy it to the Kubernetes cluster. That is actually the one-way process. But I think at the Go is hiding all this process for you and make those and all these things for simpler. So I think like during the slide you mentioned like for .NET or the GoNet. So are these using Go under the hood? Like first you compile the code in the .NET language, then it's compiled into the Go language, and then you build the images out of it. So that's how I see it. Other
Yeah.
tools like.
So right. So Jib is excuse me. Jib is entirely written in Java. I believe CoNet is entirely written in .NET. Someone can correct me if that's not the case, but in both of those cases, I believe there is not a single line of Go ever, invoked. And it's not like they are. These tools aren't generating a Docker file and then executing it, right? That would require that Docker be running on your machine to execute that Docker file. These are building in Jib's case, Jib builds a jar, right? Like an execute. I don't know enough about Java, so maybe I'm being wrong here. But Jib builds an executable jar and then puts it inside an image without invoking Docker, without involving Docker, without having a Docker file, and then pushes that image to the registry. CoNet does the same thing. It builds whatever the thing is in .NET. Again, I know even less about .NET than I know about Java, but builds the executable thing and then just puts it into an image. It doesn't have to set up a Docker file, set up a Docker CLI or anything. So there's a lot of advantages just in getting. I think that the real thing is like the very inner loop development loop, right? Like I want to make a change, run the image, see it running in the cluster, or put a log line in to say I got to here, and then run it in the cluster and see where it actually hits. That tight iteration loop is really important to optimize, right? If every time you want to make a little change, you have to Docker build, Docker push, update the reference in the YAML, apply the YAML, that gets old fast. And I think as engineers and as lazy engineers especially, we like to make that as fast as possible. I shouldn't say lazy, impatient. we're both lazy and impatient, maybe. We, every second that I can spend thinking about my problem and not thinking about how to get to the next step of solving my problem is a big benefit. So that's what code does, right? Like it just wants to get you from your code to your running app as fast as possible without all these other steps.
Yes, absolutely. And I think thank you, Kumar is actually mentioning one good thing, that thanks to the Jason for setting up the K8s GitHub action. And that is actually written, I think, if you want to go check out the blog post written by the developer guy, aka Batuhan.
Oh, yeah.
And he's mentioning his slide what's that GitHub action is. So that's a really wonderful way of thinking about it. And also, like, I think the 2-3 more questions, then we wrap up the discussion. I think right now there is in the container images and the Docker images that people are talking about the base images a lot. Previously, we don't think about base images very much, like way back in when we're learning containers. But right now we're running in the production and we think about base images a lot. And we're thinking about the build information, like how to extract this, build the base images out of these Dockerfile, out of these container images, because these are the layer-based systems. So first tell about my audience, like what the build information is, where it is lacking right now, and where this build information is available. And also I see the annotation you added into the OCI spec, and thank you very much for that. And on the OCI, here's a GitHub link to go check that out. So these questions, I would love to have your thoughts on these.
Yeah, so I guess I think the thing that Docker really does well, that Docker files really do well, is they make the getting started development flow really easy, right? Like, say, regardless of what I said earlier, you can copy that Docker file and run it and it will work. And that's great for getting started. Unfortunately, a lot of those things that it recommends, I mean, even like on the, I'm going to go all the way back time. Like this one especially, this isn't the one they actually recommend. They recommend the multi-stage Dockerfile build. But if you were an impatient engineer like I am, and you started at the top of that, and you said, this is my Dockerfile, that I'm going with this, your image is going to have a lot of stuff in it doesn't need, right? Like it's going to have the whole Go tool chain. I think this is built on Debian. It's going to have everything in Debian. It's going to be huge, the image, much larger than you need, and it's going to contain a bunch of other stuff. It's also going to be hard to find out what's in that image. Like mostly you're going to go run that image, it's going to work, and you're going to go back to doing something else, but you'll never be able to figure out what else in there. You can run Trivy scans or gripe or sneak or whatever to find vulnerabilities in there and find other stuff in that image, but it's just you're hacking through the jungle there to find all of the stuff that exists in that image, and none of it's necessary, right? All of the things you need are your Go binary, and that's it. So I think this turns into a huge supply chain problem, right? Like you not only are a bunch of things in these images you don't need, but if any of them are compromised, you are compromised. You're not just, it's not just wasteful, it's also insecure. It's also less safe for you to run. So that's another benefit of Ko. We did it, I think mainly, we wanted it out of impatience and a sense of, I don't want to push more bytes to the registry than I need to. But it also has really, noticeable security benefits too, that the image, either the image built with, the multi-stage Dockerfile build or with Ko by default, the only thing in that image effectively is your application. And so that has a huge benefit there. Ko will actually, like you said, will also write those annotations. So the image you get, the image that's running in production, says, I am built on top of Distroless at this version. And so you don't have to go digging for that. You don't have to, sort of guess whether it's built on a version of Distroless. It says right there in the annotation, I'm built on top of Distroless at this version. And if there was ever a vulnerability in that Distroless image, right? Like, again, there's not a lot in there to compromise, but if somebody happened to do it, you could very easily scan all the images in your cluster and say, hey, images, who is built on the bad version of this base image? And you would very easily be able to figure that out. As opposed to, today, I think a lot of folks would do like a SIFT SBOM, or you scan the image and try to figure out if it's based on Debian or if it's based on Alpine or if it's based on a vulnerable version of something. It's much better for that image to just say, no, yeah, it was built on top of this image, and if that's bad, you can find me and fix me. I think that's a lot better.
Yes, absolutely. And I think there is a blog post I see on the internet written by some of the people, like why it's all about base images. Like I will mention, it's all about base images. And also there's a wonderful blog post written by the developer guy, is based on this build information, you can use those Kyverno policies or OPA policy to restrict that these base images not be allowed to run on the production systems. So I think that's the best way of extracting that information out of those base images layers.
Right. When your image is very clear about how it was built, what it was built on top of, then it's very easy to write a policy on that and say, don't let, some bad version of a Distroless image came out, zap every image that was built on top of that, or alert me, or, do whatever, rebuild them right away. It's a lot easier when you don't have to scan your images to find out whether they were built on something bad. That process itself is going to be a little iffy, right? It's not going to catch everything. It's going to do a good job, but it's not going to catch everything, as opposed to saying, I was built on top of this image. If that's bad, let me know. I think base images are a huge supply chain attack surface, right? It's the classic definition of you depend on someone else's software, right? I trust the Go developers not to sneak vulnerabilities into this image, but wouldn't it be nice if I didn't have to trust them, right? If they did put something, if somebody put something into the Go image today I don't care because I don't use it. I only use the distroless image, which is very small and auditable and reproducible and a lot easier to secure.
Yes, absolutely. And I think for the last few questions, like first, like for the lot of people like very new to this, we spoke about a lot on this podcast about reproducible images, and also in the slide we see the APKO, and there's a wonderful blog written by the Chamber God people what APKO is does and distroless image. Can you explain
Yeah.
to the audience who are really new to it, like what these terms actually means?
Yeah, so I'd love to come back and talk about APKO. That's another one that I think would be a great topic. But in the next 2 minutes, I'll give it 2 minutes. APKO lets you basically select packages specifically from the Alpine package system, and say I would like an image that just contains PHP and Python. My app depends on PHP and Python for some reason. I don't know why you would do that, but I just need an image that contains PHP at this version and Python at this version and nothing else. You could do that with a Dockerfile today. Again, you could run the right Dockerfile instructions in order to build that, but it's a bit more complex than it needs to be, and it's a bit harder to tell whether you've done it right. As opposed to just saying APKO, I think the APKO YAML for that would be like 5 lines. Like here's where I want you to get packages from. I want you to install PHP. I want you to install Python. And then you can do APKO build on that YAML file, and it will fetch those packages, stuff them in an image, again, without requiring Docker, which I think is a real benefit. And because they're declarative, you don't have to guess what order things happen in, right? It's just put Python in it, put PHP in it. That's all I want. Or whatever packages, Python and PHP is a weird example, but let's say I want Git and Git and Go in an image. I can just build an image that has those 2 things and nothing else.
Yes, absolutely. And for the just last question from my side, so people were thinking about like I'm writing the Dockerfile myself and building the images and pushing the images to wherever I like it to be, and somebody else is writing the Dockerfile for me. So in what cases, like I want to write a Dockerfile, and in what cases somebody else, like we as a developer, like I really have to very slow process for me to build the code and then to run the job, write the Dockerfile, build the image, push to the Docker Hub, and then deploy it to the Kubernetes cluster. And in able to make one change into the whole code, I will have to hop through 7 different stages of software development, inner loop development. And that's very, very frustrating for me. And cri-o solved this problem. But somebody has like, when is the not useful case for me to ask somebody else to write a Dockerfile for me?
I think Dockerfiles are, you will still need a Dockerfile if the image you're trying to build is very complex, right? Like if it needs files in particular places and these particular versions of this thing, if the product you are trying to produce is very complex, it is maybe worth the complexity of writing a Dockerfile to produce it. But if you just want a simple image, you shouldn't have to write a ton of Dockerfile just to produce a simple image that contains, 2 packages or whatever. What's the question here? If you only want a container as artifact to distribute, would you suggest Co rather than Go Releaser? I'm not sure. I mean, in general, my answer to questions like this is always, if you are happy using Go Releaser, use Go Releaser, right? Go Releaser is also great. We use it in Co actually to build and release all of Co releases. If you're only using Go Releaser to build container images and not binaries, it might be worth using Co instead. But if you are successful with Go Releaser, I won't feel bad if you keep using it. I think there was at one point an effort, I think actually from Developer Guy, to get Go Releaser to use Co, or to be able to use Co internally when you build a container image. So maybe the answer is actually yes to both, and they'll both be the same thing.
Question. Yes, absolutely. And next question: with APKO, we can get packages we want as a part of our distroless images? Have I understood it correctly? How this works under the hood?
Yeah. So, slight tangent into the history of the term distroless. Distroless basically means any image where there isn't a package manager, right? In my head, that's kind of what I think is like if the image contains packages but no way to install new packages, that's my mental image of a distroless image. Classically, distroless images have been built using Bazel, which is another very complex tool with a lot of sharp corners. But if you need it and you get the benefit of it, you should use Bazel. But the way that works is Bazel distroless fetches from the Debian package ecosystem and extracts those and puts those into an image and just says, here is your image containing only the 2 packages you wanted and nothing else and no way to install new things. APKO is, I think, the next level of evolution after that, which is instead of using Bazel, which again is very complex and very wordy to get those 2 things packaged into your image, APKO is just YAML and again about 5 lines of YAML to say, go fetch these APK packages, put them in an image and nothing else. So APKO is, I think, a lot easier way to make a distroless image. And it's so easy that like you can go make your own. If you want a distroless image that has, Git and Subversion and Perl, that's 5 lines of YAML to get that for you. And if you decide one day you also want to add some other tool, you just add it to the YAML and APKO build, and it's just that easy. It's not that easy with Bazel. You have to do a lot of other stuff. APKO is much simpler.
Yes, absolutely, and that will definitely be covered again in the future podcasts as well.
Yeah, we should do that.
And absolutely, we definitely cover this. And also we talk about a lot on this show the developer guy, and I will shout out to him. He's become a sponsor to the GitHub. So everybody listening to us or watching to us, his repository is one of the favorite of mine. His contribution to so many projects, like I can't even explain in one show, like where he contributed. So I think definitely everybody listening to, watching to us, this is a link for you. He's been responsible of a wonderful contribution to the CNCF Cloud Native project. So please sponsor to developer guy. Yeah. And also Bill, absolutely. And before I let you go, is last one question more, like from where APKO fetches the package, Debian packages?
APKO fetches APK packages from the Alpine ecosystem. So generally you find those on packages.alpinelinux.org, I think. But yeah, another topic for the future APKO talk. We will definitely.
Yes, absolutely, definitely. We'll definitely cover it. And before I let you go, the final question. Yeah. Because I hope you are going to the KubeCon, and your KubeCon talk is going to be very near to us. So what the talk was and what we're learning from this talk.
So can't wait to see everyone in October in Detroit. I'm going to be giving a talk on securing the supply chain of your infrastructure as code. We haven't written it yet, so I don't know exactly what it will be about, but that's the topic. And I look forward to talking to folks more about that as we get nearer.
Yes, absolutely. Thank you very much, Jason, for being in this show. And let me conclude everything. So K8s is a simple, fast container image builder for your Go application. Go simplifies building container images. Also, it securely does that by providing features such as not requiring any daemon process without the need for Dockerfile, providing build information for reproducibility, and creating and pushing SBOM software bills of material. So this is all done by the K8s behind the scene for you, and a great tool. So keep an eye out for this wonderful tool. And thank you very much, Jason, for joining us on this podcast. Hope to catch up with you again. So stay safe, stay healthy, everyone. Hope to see you. Bye-bye. Stay safe and stay healthy.